Once a section of trench had been completed, up to 9 side booms were used to lower the string into position in the bottom of the trench. Although a difficult process, an average of 1,000 metres of pipe string was lowered in on a daily basis. In the UK, Transco, in conjunction with the landowner and farming communities, set national standards for all aspects of its work, including the consent process for the construction of the project.
The compensations that are given to the farmers are based on an agreement between Transco and the NFU, and it's a set figure per linear metre, and that's non-negotiable, so that nobody gets more than anybody else. We also get claims in for other various types of compensation, such as crop losses and loss of amenities, and these are discussed with farmers and via Transco's land agents.
Our main concern as an arable farmer must be the soil structure and the drainage. It's our medium that we grow our crops on, so it's very important that the soil structure is left in a usable fashion.
The main problems are convincing farmers that you do care about the land and that you want it to go back as good as it was before. I think the lessons we've learned on the St Fergus to Aberdeen pipeline in dealing with the farmers is that we have to be upfront with them, we have to involve them, ask their opinions, and we have to show them that we care about what they think.
Where excavation was impractical, such as when crossing roads, railways or rivers, a method of trenchless pipe installation had to be adopted known as auger boring. This technique involves driving the pipe through the ground and was used frequently during the project due to the high number of overground obstacles, the largest obstacle being the River Don. The crossing of the River Don took over 12 weeks from start to finish. The majority of that time was spent preparing the cofferdams for the micro-tunnelling subcontractor to work within. The tunnelling operations itself only lasted 12 days. Micro-tunnelling, which is an advanced form of trenchless pipe installation, was used as it posed the lowest risk to the personnel involved and to the integrity of the river.
It takes approximately a week to set up the gear to do the job, and then we're going to push one 12.5 metre pipe on the night shift. Then Transco welders will weld and X-ray and test the pipes on the day shift, and then we'll come on night shift again and push again.
Although difficulties were encountered with varying ground conditions and steering of the rigid steel pipes, the tunnelling works were still completed successfully and on time. Where the pipe had been installed by trenchless methods, it had then to be tied into the main line. To achieve this, the main line was lowered in to overlap alongside the crossing pipe. The tie-in crew cut the main line to the correct size, butted the pipes together in the pipe clamp, and then carried out the tie-in weld. After the tie-in, radiography, coating and backfill were carried out as per the main line.
Top stories in Scotland today at 6.
Foot and mouth disease is spreading as a third case is confirmed and more farms are tested.
When planning any project, it's always impossible to expect the unexpected, and sure enough, Transco could not have planned for the outbreak of foot and mouth disease across the UK in 2001. But once alerted, Transco immediately sought expert advice from specialist government bodies and farming organisations. Individual farmers along the route were quickly consulted and all recommendations were implemented. Although foot and mouth never reached Aberdeenshire, the precautions were kept in place until all the areas were declared safe and the local farmers were happy for the precautions to be removed. The result was a 6-week delay to the start of the project. A high standard of reinstatement was critical. These standards are set in agreement between Transco and the national farming organisations to ensure a rapid return of the land to agricultural production. Where ground conditions were suitable, the excavated material was graded and used for padding around the pipe. To maintain the high speed of operations, a pipeline padder was used for this purpose. This self-contained machine travels along the excavated material, loading itself by conveyor. It then screens the material to the desired size before it's deposited around the pipe by a second conveyor belt. Subsoil was then pushed back on top. Once reconstituted, the topsoil was loosened by a process of ripping in order to speed agricultural regrowth. As part of the reinstatement process, post-construction drainage was installed in areas where the pipeline easement was not on free draining land. This prevented the areas becoming waterlogged during periods of heavy rainfall. Designed in conjunction with the existing land drainage system, these drains were tied into the pre-construction drains. The outfalls from the pre-construction drains were used to take the collected water to the local ditches and drains wherever possible. After final reinstatement, the field boundary and road boundary fences were replaced with new fencing to match the style of the original fencing. It was also important to retain the unique character of the countryside, and so Transco's contractor employed dry stone dike experts to rebuild the dikes that had been dismantled along the pipeline's route.
After reinstatement, we would hope to get a crop in there as soon as possible, because there's nothing helps soil structure more than if you get a good crop properly established and the roots getting down there. And from what I've seen of the reinstatement process, it seems to be going very well.
Once tie-ins at special crossings and backfilling was complete, the pipeline was subject to a high-pressure hydrostatic test, which finally confirmed the pipeline's integrity. Once all hydrostatic testing was complete and test sections tied in, the pipeline was dried using super dry air to ensure that no residual water remained in the pipeline from the testing process. The new pipeline was then commissioned by the direct purging process. Gas was introduced from the energizing source at St Fergus at a set velocity. The air then evacuated from the pipeline was vented at Aberdeen through a special silenced vent until 100% gas was achieved. The vent was then closed and the pipeline pressurized to full line pressure. By August 2002, and having taken over 4.3 million man-hours, Transco's ambitious 72-kilometre pipeline from St Fergus to Aberdeen was finally complete. The project team faced many varied challenges at each stage of the process, including the introduction of large-diameter, high-strength steels and the use of automatic ultrasonic testing techniques.
This has been achieved with a high standard of safety, very high standard of environmental care, and really is a major achievement for Transco.
The culmination of 3 years' hard work, from the initial feasibility study to a working asset, the pipeline is testament to Transco's skills, energy and determination to meet the future gas demands of our customers.